Did you think that building reliable software that users love would be easy? I did. I've been coding since 1988. I built software that managed more data than Facebook and Twitter combined, and eventually started my own software business. But it was a grind. So to help you ship with less pain, here are 20 things I learned that will help you deliver better software faster without burning out. Lesson number 1. Have you ever been to a morning stand-up where everyone was waiting for a review and no one wanted to be the one doing them? I have, and it drains my energy faster than a full day of meetings. So when I got enough of waiting, I asked my team to pair code and push directly to main instead. People were worried that pair coding would waste time and that the lack of code reviews would lead to bugs. But neither of those things happened. Our velocity doubled and we had way fewer bugs than ever before. Code reviews give you a false sense of safety. If you want to move fast, stop doing them. Lesson number 2. Once I found out that engineers on my team started sending Git patches on Slack, and it was all my fault. I was leading a bootcamp to onboard new engineers at the company. Eager to teach them continuous integration, I told them never to use branches. I hoped it would encourage them to make smaller changes. But that isn't what happened. When they needed to hand over a large unfinished task, they found a solution that matched the constraint. They followed the rule blindly because I didn't explain why it existed in the first place. These days, when I work with teams, I spend time pair coding or even ensemble coding with them. When I model the right habits, they pick them up instantly and go on to advocate for them in their new teams. Turns out, it's not rules and frameworks that make teams agile, but the culture that created those rules. Lesson number 3. In 2015, I was building a software product that became the foundation for my business, but I almost gave up before the first release. My low point was Christmas Eve. By that time, I was working on it for about 6 months. Before joining my family for dinner, I closed my laptop and decided to quit. A few days later, I gave it another shot. This time, instead of grinding through my endless list of ideas, I focused on the things that I needed for release. 2 weeks later, I shipped, but I was sure it was going to flop because it was nothing like my vision. Guess what? People loved it. Turns out most of the features I planned or already built weren't even necessary. That initial release showed me what actually mattered. Things I never even considered. Build the simplest thing possible and release it in 2 weeks, even if you think it's garbage. What makes products awesome isn't your vision, but the feedback you gain from customers. Lesson number 4. Did you ever have a great idea only to find that someone already built it? Most people give up. And here's why that's a mistake. In my workshops, I divide engineers into teams for competition. They need to improve bots that are already playing a game against each other. You'd expect the most sophisticated strategy to collect more points and win, right? But I found the opposite. Complex strategies take longer to build, so the team that ships something simple gains an early advantage. And even when the complex strategy finally deploys, the other team can find a weak spot and beat it with something simple. Once I noticed this, I changed how I build products. I find one thing that makes my product better than the competition. Then I build that. Users will switch for the one thing they really need, even if the competitor has hundreds of features they don't. So when someone already built your idea, ask, what would make this even better? To win, your product just needs to be a little better than the competition, and users will flock to it. Lesson number 5. Did you ever ask yourself why we keep estimating stories 3 months ahead and then miss the deadline every time? But that's not even my main problem with long-term roadmaps. Once my team started releasing every week, we realized most of our stories were pointless. We dropped them, added what we thought mattered, only to scrap them a week later. So we changed our approach. We choose the next most important thing we can build in less than a week. We are not just saving time on pointless estimates, we are focusing on what users really need and ship it sooner. Estimates beyond a week are harmful. They become irrelevant and encourage sticking to a flawed plan. Lesson number 6. If you think building features nobody needs is a waste of time, it's not. It's way worse than that. I was working at a startup and we had a feature that customers constantly complained about. Every other month, a client threatened to leave because their customers weren't receiving the emails they should have. But we had a problem. Fixing the issue would break another feature. It used to be one of the most requested features, so we definitely didn't want to do that. After about a year of this, I had an idea. What if we built a simpler version everyone understood and only kept the complex one for those who asked for it? Our product manager loved the idea, so we built it. But before turning on the new version, I checked who was actually using the feature that had blocked us. Guess how many customers were using it? A few would be an understatement here because absolutely no one used it, not a single customer. So if a feature is causing you headaches, check if people are still using it and delete it if they aren't. Lesson number 7. You're watching this video, so I'm going to assume that you care about doing a great job, right? Sometimes that can be your worst enemy. My team and I were building a workflow engine. After adding action nodes, the next request was analytics for them. Since this was a company where we took pride in building well-crafted software, we decided to introduce a visitor pattern. It would let us add analytics without making changes to the action nodes. So what's the catch? Every time we added a new action node, we had to change the two visitors and their base class. We never needed to add more visitors, but we kept adding action nodes and the visitor classes had grown absolutely ginormous. The situation became even more painful when we wanted to expose an API for building action nodes. The visitor pattern made that practically impossible. So we eventually refactored and deleted the visitors. That is how we learned that over-engineered code is just as bad as spaghetti. Keeping your code simple is a superpower. Lesson number 8. Now you might ask, if the visitor pattern was such a pain, why did we wait with the refactor for so long? Well, we tried multiple times, but we had to give up after a few hours. By the time we realized the issue, other parts of the system already coupled to the visitor class in weird ways. But we knew that it had to go, so we made a commitment. Every time someone noticed the dependency, we would break it. A couple months later, we ran into the same issue again. This time, it only took about 2 hours to fix. If you can't solve a design problem right away, don't give up. Keep making small improvements until the original problem becomes small enough to fix. Lesson number 9. Knowing all features of a programming language doesn't matter, and it's not because of AI. Shortly after I joined the team for the first time, I read Effective C++ by Scott Myers. I was still quite junior and eager to try every new feature I learned about. So when I got the chance to redesign a part of the codebase, I used the full arsenal. Then my team and I spent weeks debugging template initialization gotchas. My clever design had slowed everyone down, so we eventually replaced it. We delegated that complexity to a library that made it look simple. That is why most of us only need about 10% of the language. The rest is there for those building the libraries we rely on. Lesson number 10. As a developer, we are constantly being told that we need to stay ahead of the curve. And that's true. But following that advice too much can backfire. When I started building my first product, Lean Developer Experience, I saw it as an opportunity to learn new technologies. So I used Ruby as the language, MongoDB as a database, and Thrift for remote procedure calls. I spent more time trying to learn these technologies than building the actual product. What made things worse was that both Mongo and Thrift were brand new at the time, and the support for Ruby wasn't really good either. I got rid of Thrift quite early on because it turned out to be a short-lived hype. Once I switched to a REST API, the system got over 100 times faster, and adding new features got easier too. When it comes to MongoDB and Ruby, those stuck around for a decade, and I never really used either of them outside of this project. If you build something important, use the boring technology you already know well, and add only one new technology to hobby projects. Lesson number 11. What if I told you that you can do test-driven development without unit tests? At the time, I was working on a data warehouse project and we had to create a report for the customer. Since the reporting tool we used wasn't designed with testing in mind, we spent a ton of time writing and correcting tests. After 2 weeks of work, we showed the report we built, and the customer immediately had a bunch of change requests. I wasn't sure whether I understood them correctly, so I made a small change and showed the user. We ended up iterating on that dashboard for 5 hours straight, always just refreshing the report and checking the result. It was very effective, but all of our tests broke in the process. And yet, it felt like we were doing TDD. Just by refreshing the page, we could validate whether we broke anything. That gave us the feedback loop that we love TDD for, and we could iterate much faster. The key feature of TDD isn't the automated tests, it's the instant feedback you get from them. Lesson number 12. I used to think tests were the ultimate safety net, But once I learned this, it completely flipped how I build software. When I joined that team building the workflow engine, it was already a constant source of firefighting. The team was full of brilliant engineers. We had hundreds of automated tests and a dedicated tester. Yet the bugs kept slipping into production. And when the customers complained, we couldn't even find them. So we did what we should have done a lot sooner. We turned our most important end-to-end tests into monitoring and added detailed logs. Turns out, most of our issues came from race conditions that only happened in production and downstream errors in other services. The running joke was that our service became the monitoring system because we found bugs in other team services before they did. Since then, I always stop monitoring and logging before writing a single line of code. It is the one thing I trust more than my tests. Lesson number 13. Once we had that monitoring, we noticed that some users were doing things that really hurt performance. One of our customers had over 100 unused segmentation runs after an email. It must have been an absolute pain to set it up. The problem was that this clogged up the job queue, delaying important jobs for other customers. Thinking this was obviously a dumb mistake, we asked the customer to delete them. But then this exact same thing happened again, and then again with a different customer. So we decided to talk to them directly. Turns out they needed a report on how many customers from each country got their email. They set up a filter for each manually, copied the numbers from each node, and subtracted the previous week's count. I honestly admire their persistence, doing that for over 100 nodes every single week. Eventually, we built them a node that generated that report in a single step. It not only made them happy, it also solved our performance issues. So, if you notice that users misuse your product, it's not because they are dumb. It's because you haven't built what they need yet. Lesson number 14. How would you feel if this test failed and you had to figure out why? Can you even tell what is being tested? Tests like these are hard to write or understand, and they are extremely brittle. Eventually, we got tired of fixing a dozen of these every day. We built a small custom library that turned our tests into something more like this. Now it's clear that we are testing a workflow engine. What are the steps in the workflow and what we expect? The tests also didn't break as often, and when they did, fixing them took a fraction of the time. That tiny library paid for itself within a week. Build your own tools. They have compounding returns. Lesson number 15. Recently, I was working with a team and they had a huge C# code base with no tests and tangled dependencies. Some parts of the code were older than some of the developers on the team. If you ever worked at a large company, you probably know how hard it can be to add tests to a code base like that. On the other hand, I had an idea for a tool that would make this really easy. I just never had the time to build it before. But I had a crazy idea. What if I asked Claude Code to build it for me? Now, this was a library that required some clever tricks and a deep understanding of language features, so Claude couldn't do it on its own. But it got close enough that in a few days I built the library now known as SpecRec. But the real lesson isn't that you can use SpecRec to create characterization tests really fast. It's that even if a tool felt too expensive to build before, it might just be viable now. Even if the AI can just build half of these tools with minimal work, the returns from those will be well worth the effort. Lesson number 16. Not long after I built SpecRec in C#, I ran into the same problem, but with Java. This time, I didn't have days to build. Instead, I asked Claude to describe how the C# version is implemented and adapt the plans to Java. After I made some small changes to the plan, Claude built the Java version essentially on its own. LLMs are great at translating between languages, so you can use them to port small libraries. Actually, fun fact, the transformer architecture that made ChatGPT possible was originally designed to improve Google Translate. Lesson number 17. Did you notice that the bigger the code base, the more mistakes AI coding agents make? How you react to that can either speed you up or wreck your productivity. I used to just ask the agent to fix the issue. When it failed repeatedly, I opened the code and cursed when I saw the mess it created. It was rather painful to refactor just to understand the code. Often, I ended up spending more time fixing the code than it would have taken me to write it myself. Then one time, I was in no mood to understand it, so I decided to ask the agent to refactor. To my surprise, it didn't just do that. It immediately fixed the bug too. When the AI struggles, treat it as a code smell and ask the agent to refactor. It won't help every time, but it can save you hours of frustration. Lesson number 18. Most AI coding gurus will teach you prompting techniques, but that advice might be holding you back. Initially, I was obsessing over trying to prompt the perfect code into existence, but it never worked. So once I realized that the AI can actually refactor its own code when asked, I changed my approach. Now I let it draft first and then ask it to refactor. But here is the trick that elevated that to a whole new level. I asked Claude to build a script that detects code smells like long functions, deep nesting, or feature envy. Then I added these to my post-commit hook and prompted the AI to fix the issues detected. As a result, the agent can now handle entire features independently. Building the right quality checks is way more important than prompt engineering. Lesson number 19. Did you ever look at the code and thought, boy, I could rewrite this so much better? Well, I felt that a lot of times. I started my career as a freelancer building websites. When one of my new clients handed me code I didn't understand, I convinced them that we should rewrite it from scratch. It seemed like a simple app, and I honestly thought it was going to take me about a week. 2 weeks later, I was nowhere near done and I lost the client. So next time when a client handed me a terrible code base, I spent time cleaning up just the part that I had to work with. At first, it was a grind, but over time, it got easier and easier to work with the code. Rewriting from scratch is a trap. Resist the urge, just clean up the part that's in your way. And that leads me to lesson number 20. But what if you can't fix the issue with a small change? That was exactly our problem when a customer threatened to leave unless we fixed their daily import process that took 25 hours. The code was inherently flawed, updating every single field in the database in a separate transaction. The only way we had any chance of speeding it up is to fundamentally change how the import worked. Terrified to lose a large customer, we decided to build them a custom import. It worked just for them, but it ran in a couple of seconds instead of hours. But here's the clever part. Since moving customers to this new import had a positive impact, we started adding features to it. Within a few months, all of our customers were on this new import. If you can't avoid rewriting a system, make sure you do it in small steps, and there is a clear business benefit to it. All of these lessons are incredibly powerful, but if you don't know how to fix a code base so complex it makes quantum physics sound like a walk in the park, neither of them will save you. So watch this next video where I show you the exact framework I use to replace legacy code, so you can finally turn that terrifying monolith into the greenfield project of your dreams.